This is Agent Clark from the ASPCA reporting on the Shepherd case. Ellie Shepherd got 2 cats in the summer of 2012.
I sure love cats. I think I'll get him. I'll name him Monica. Come on, Judy. Welcome to your new home. Come on. Hey, kitty.
This is Copernicus. He's very friendly. He is 2 years old. He's very soft, as you can see. He's very picky with his diet, but he's a rewarding pet.
I think I'll get him. Hi, kitty. Welcome. Welcome to your new home. Come on. There you go.
Here at the ASPCA, we are investigating Mrs. Shepherd because she is letting her cats reproduce at an alarming rate, with the population growing exponentially.
I sure love my cats.
While Miss Shepherd's cat population does not yet violate county code, it is only a matter of time. To predict the amount of time it will take for us to be allowed to remove the cats from Miss Shepherd's care, we sent our data to one of our experts. To the lab. Our first equation is y equals 2 times 1 plus 0.5 to the power of t, where 2 is the initial number of cats, 0.5 is the rate of growth, and t represents the number of years passed. The equation will answer the question, how many cats will you have after any given number of years, by solving for y. In our example problem, we plugged in 8 for t, meaning after 8 years, how many cats will you have? Entering the values into a calculator, the solution is 51.3. However, since you can't have 0.3 of a cat, we rounded to 51 cats. Our second equation is the same as the first. However, instead of solving for y, we plug in a value and solve for t. Thus, the equation answers the question, how long will it take to get a given number of cats? In the problem, we plugged in 200, the amount of cats desired, and like the first problem, 2 is the initial number of cats and 0.5 is the rate of growth. In the example problem, we first divide both sides of the equation by 2 to isolate the base. This gave us 100 equals 1.5 to the power of t. Then, using properties of logarithms, we added ln to both sides and moved t from the exponent. Then, to isolate t, we divided both sides by ln of 1.5, giving us a solution of 11.358, or a little over 11 years. Thus, it will take Ellie about 11 years to accumulate 200 cats. Using the first equation, we create a table of the corresponding x and y values, graphing time in years past on the x-axis and the number of cats on the y-axis. Since this is a growth equation, the number of cats increases exponentially as time goes on. Since some of our y values were decimal numbers, we rounded up or down to achieve whole cats. Research, in approximately 5.5 years, Mrs. Shepherd's number of cats will violate El Paso County Code and the ASPCA will intervene.